Good morning. This is Wednesday, February 17th. We have a lot to cover today. We're on to our second part of the class, but before we move on to that second part of the class, I do want to talk a little bit about the exams. I'm not sure what the appropriate word to use is, so I'll just use the one that comes to mind. The exam scores overall were disappointing. Again, this is a 431 class. I know not everybody came from different 430 instructors, but you were supposed to have been successful in 430 to be here. And so being able to tackle this type of material is something that should be secondhand to you by now. And again, averages are one of those things that you have to always take with a grain of salt, especially on the first exams, because there's such a wide variety. Notice as I put here, the lab exam one's average was 57, but as you can see, the high score was actually with the curve an 84.5, and the low was a 4.5. Same thing with the lecture exam. While the average was slightly better with a 66 and change, the high was a 95 and the low was a 24. Now, I don't put these highs and lows on here to make two people feel really good about themselves and two people feel really bad about themselves. But I put this on here to remind you of a couple things. The first is that everybody, even with a second semester class like this, comes in with different expectations. Maybe your first semester instructor wasn't as vigorous as they could have been. Maybe it's been a couple semesters since you took the first semester material and you've kind of forgotten how to do it, or maybe you just got too much on your plate with this online environment. I know a fair number of you are also taking micro at the same time. What I want you to use this first exam for is a learning experience. Yes, if you did well, you can be happy with that. And plenty of students did do well. But again, don't strain yourself, patting yourself on the back. And that person who was successful certainly can't cruise till the end of the semester without having to do any work. They should take heart in the fact that they were successful in the first exam. And so the way they're preparing for this class is working. For those of you who weren't as successful as you wanted to be, I don't think that you should necessarily go and flog yourself after class today, but realize that the way that you attacked this first section of material is not going to allow you to be successful, and you need to change how you're going to attack this material to be successful. The good news is you now know exactly what to expect from me. The same way I wrote this first lab exam is how I'm going to write all the lab exams. The same way I wrote this first lecture exam is how I'm going to write all the lecture exams. So you know exactly what is expected of you, how I'm going to ask the questions, and what I'm looking for in the answers. So whether you did well or whether you didn't, use this first exam as a learning experience. There are still two really good pieces of news. The first is that your grade in this class is based on all of your points, not just the exams. And as you can see, the overall grade right now is just under 80%, which is not bad. The other thing to remember is we're going to finish this class somewhere between 1,200 and 1,300 points. And remember, total. Oops. And remember, your final can replace the lowest lecture score. So if you ended up at the low end of this lecture score, it can go away entirely by being replaced by the final. So there's still lots of time. In fact, mathematically, every single person in this class is still capable of getting an A. All right. But some of you are going to have to work harder to get there than others. Now, one of the things I want you to do is, again, learn from this first set of exams. And so after class today, I will be releasing the exams for review. You will have about 24 hours to review your exams. So again, I make these available so that you can go back and you can look at the things you were successful with and the things that you weren't. Again, with grading all of the exams, I can only put minimal comments on them, and I can't grade them the same way I normally would with a red pen on the exam, but hopefully you can look, and I've tried to make some notes to try to help you to clarify what's missing or what I was looking for. If you have questions about that, come to my office hours, go to email me, make other arrangements to be able to do that. And I'm happy to answer those questions for you to help you to, again, be successful. After those 24 hours, so sometime tomorrow afternoon, I will then be closing the exams again. And then if you want to see them after that, you can come to my office hours so we can go over them together. All right, so again, some of the key things that I think people really need to make sure that they are careful about on these exams is first, make sure you answer all parts. Many questions have 2 or even 3 parts to them. And it's awesome if you give me all of the first part, but don't give me the second, and that's going to be an issue. Also, never, ever, ever leave a question blank. All you do if you leave a question blank is you guarantee yourself with 100% certainty you are getting a 0 on that question. One person from one question actually wrote Long Island iced tea. And while obviously they didn't get it right, they still had a better chance of getting that answer right than if they had left it blank, right? If nothing else, they made me happy. And so maybe I gave them an extra half point on the next question because I was in a better mood. Who knows? The point is that this is true, obviously, for the lab exam, but it's even more important for the essay questions, right? Yes, with an essay question, if you know all of the information, you're getting all of the points. But even if you just give me some of the information, you're going to get some of the points. And those little bit of points, half a point here, point there, all make up and make a big difference that way. So make sure you are doing those types of things. So review the exams, see what you can do to be more successful. If you're not sure, meet with me and I can help you with that as well. All right. Any questions on the exam related stuff?
I have a question.
Yes.
I find the physiology to be just a lot. Do you think that those Science Fridays are helpful with physiology, or is that more geared towards anatomy?
Jeff will answer any question that you ask him. Unfortunately, the way it is set up, it's probably more relevant for, because what he has are the lab materials that are going to help more with the anatomy stuff. If you're having difficulty or challenges with the physiology stuff, you're welcome to ask Jeff about it. But the other thing you can do is come to my office hours and talk to me about it. Or email me and we can discuss things that way as well. So I don't think it's necessary. I mean, like I said, he's not going to say no and not answer a question that you ask him, but I think it's more to look at the models and the charts and the anatomy stuff is there. But it's an open lab, and as an open lab, he'll answer any questions that he can. All right. Any other questions on the exam stuff? All right, that's the doom and gloom. Let's talk about the fun stuff. Let's talk about what we're going to be doing in this section. We are going to be discussing the lymphatic system and the endocrine system. And then obviously along with that lymphatic system is our immune response. So we have 3 heavy concepts. I guess the one last thing I would like to say is I'd like to tell you after this first lab and lecture exam that it gets better from here, but I'm not sure that's entirely true. This second section tends to be very challenging because it's less intuitive stuff, right? The heart is something you can hold in your hand and look at. The blood vessels are things that we can look at. With the immune response, with the lymphatic system, with the endocrine system, there is a massive amount of cellular and chemical interactions. There is a massive amount of histology. And I know some people, and especially some people who didn't have me for 430, may not have emphasized histology as much in their 430 class as they should have. My class did. In my class, the people who had me in 430 can tell you that histology is not necessarily fun. And the reason it's not fun isn't that it's necessarily inherently hard, it's just not intuitive. And there isn't an easy way to do it. It really just takes time and effort. There's no simple path to learning the histology. You have to put in the time, you have to put in the effort to get used to looking at these histology slides and making sense of them. So this is a challenging section. And I think one of the other things that people get lost in this section is there's also a big group presentation. So today in lecture, we're going to talk about the lymphatic system, and then we're going to talk about the group presentations. And then I'm going to break you into groups, and you guys are going to pick your topics and spend the rest of the lab time focusing on organizing on how you're going to attack that material. Because you are working on these group presentations, there's not as many homework assignments in this section, because anytime you would be normally spending on homework, you'll be spending on your presentation as well. But there are a couple. We have our Unit 21 review that you're going to be due on Monday, the 22nd. On Monday, March 1st, your PhysioX Exercise 12 Activity 3, the ELISA test, is going to be due. Again, notice I don't have Wednesday the 24th listed there, not because it's a holiday, just because we don't have anything due on that day. Although, as a hint, anytime we have a day there is an assignment due, that always makes for a good day for a daily quiz, so you never know about those. And then the Labster Intro to Immunology is due Wednesday, March 3rd. And again, like all the Labsters, you have to have it 100% complete and at least 80% correct for full credit. Now, you are going to be doing your group presentations on Monday, March 8th. Part of that presentation is going to be presenting an outline with your references. And again, we'll talk more about this when we get to that part in class today. For the students and for me, that's going to be the references and the outlines are going to show the breadcrumbs of your path that you're going to present for people. Those are actually going to be due on Friday the 5th. I want them to be available over the weekend so people can start looking at those, because your exam on Wednesday, all these group presentations, you are going to be responsible for that information on the exam on Wednesday, 2 days later. So having the outlines available over the weekend so people can start looking at them and seeing what's going to be expected of them for that exam is going to be important. Since we're online, I'm going to take advantage of that, and we're going to have an assignment due on a day that we don't normally meet. I will give you lots of reminders of that because it isn't a time when we normally meet, but those outlines need to be turned in by 6 p.m. on Friday the 5th. And if they are late, they will be 10 points off of your assignment. And remember, this is a 50-point assignment. So 10 points is a huge chunk of that. That means the best you can get is a low B. So it is important to make sure that these are turned in and turned in on time to help other students be able to prepare for the exam. All right, and like I said, we'll talk about that more when we get to that later today in class. All right, and then that second week of March is my spring break, because I don't have to do anything. On Monday, you guys do your group presentations, and on Wednesday, you take your exams. So I'll be sipping my pina colada, wearing my Hawaiian shirt and straw hat, probably on a beach somewhere, and enjoying myself while you guys are doing all the work and sweating and crying. All right, questions on any of that? All right, excellent. And yes, 8 o'clock in the morning is a perfect time for a pina colada. All right. Excellent. And remember, it's not considered day drinking if it's a Bloody Mary too. So remember that too. All right, excellent. I'm pretty sure that's what Daniel's drinking right now. All right. All right, excellent. With that in mind, let's go ahead and start on our lecture. Oh yeah, mimosas. There you go. That works too. Irish coffee. See, day drinking, totally acceptable. All right, excellent. You guys came up with those answers a little too fast. All right, excellent. So we are on to the lymphatic system. I'll be honest, I don't remember if it's this version of your textbook, but I know the previous edition of your textbook actually started this section out because, you know, at the introduction saying they can't all be rock stars when it comes to the organ systems. And so the lymphatic system is kind of the redheaded stepchild of the organ systems, doesn't necessarily get the credit that it deserves. Of course, like all organ systems, it is comprised of primary organs and accessory organs. The primary organs of the lymphatic system are the lymphatic vessels. And then also we have accessory structures that include other organs, tissues, and cells. So we have things like our lymph nodes. We have things like our thymus and our spleen, our red bone marrow, our tonsils, and our mucosa-associated lymphoid tissues, which after you've written out once, you can abbreviate MALT. And of course, these contain our fluid, one of the humors of our body, our lymphatic vessels do at least, called lymph, and we'll talk about that as well. And of course, we have a pretty picture that goes along with this as well. So let's talk about the function of the lymphatic system. One of the things we talked about in the cardiovascular system when we looked at the capillary exchange is we saw that the force of the outward filtration that occurred at the arterial end of our capillary was greater than the force of the reabsorption at the venous end. And we talked about the implication of that is more stuff gets pushed out of the capillary than is reabsorbed back into it. So our capillaries are essentially leaky. It's not a significant amount, but it is enough that over time we would lose all of the fluid in our blood, and that would definitely be a bad thing. So as we talked about back in the last section, our lymphatic system is responsible for collecting that fluid and depositing it back into the cardiovascular system. And it doesn't just do it blindly where it closes its eyes and scoops it and dumps it back in. It is going to monitor and filter that fluid, looking for dead, abnormal, damaged cells, looking for harmful pathogens, looking for things along those lines. So our lymphatic system's job is to take that excess interstitial fluid and drain it, help to mediate edema, right? As we talked about, we know that there are those four forces that influence the capillary: the hydrostatic pressure of the capillary, the osmotic pressure of the capillary, the osmotic pressure of the interstitial fluid, and the hydrostatic pressure of the interstitial fluid. That's the force of that interstitial fluid pushing on the capillary. So by taking that interstitial fluid and draining it away from the tissues, we keep that hydrostatic pressure of the interstitial fluid very, very low. And that way we can maintain the normal filtration and reabsorption that occurs at our capillaries. Our lymphatic system, especially as it is related to our digestive system, plays an important role also in helping us to be able to package, modify, and transport lipids, both dietary lipids and lipid-soluble vitamins, right? You have that nice big greasy cheeseburger for breakfast, and you don't necessarily want all the fat of that dumped into your cardiovascular system right away. So our digestive system has a lymphatic system that plays an important role in the draining of that, the processing, the storing, the filtering of that to help to mediate the movement of those lipids into our blood supply. And like I said, this plays a very important role in the defense. Monitoring it. It's not just blindly taking this fluid and dumping it into the cardiovascular system. It houses a large number of leukocytes that are monitoring, looking for, again, harmful pathogens, abnormal cells, dead and damaged cells, foreign material, all of that type of stuff that's going to play an important role in providing our defense to maintain the health of our body. Right. Again, it houses many of the cells that are responsible for what we refer to as our immune response. Remember, we do not have an immune system, right? Systems involve organs working together. We have an immune response, which is a chemical and cellular interaction that provides our body's protections. All right, questions on that? All right, as I mentioned, the lymphatic vessels are involved with moving humors of our body, the fluid of our body, and that is lymph. And again, lymph, if you think about it, is very similar. Most of the humors of the body are similar. A lot of their names are basically based on location. As we talked about, the water and the stuff dissolved in the water, when it is in the capillary, we call it plasma, right? But as soon as it's forced out that capillary into the tissues, we call it interstitial fluid. And when it gets taken up by the lymphatic vessel, that same water with that same stuff dissolved in it, we call lymph. So when we talk about the humors of the body, lymph, blood, interstitial fluid, all these things, they're very, very similar because they're pretty much interchanged with each other. but they're not entirely the same, right? Plasma, the blood obviously has our formed elements, our red blood cells, our white blood cells, platelets, large proteins, and things along those lines, right? That obviously aren't in the interstitial fluid. So there is some variation in these, and the lymph is the same way as well. Also, because it is involved in the movement of fluid, not surprisingly, there are some similarities between the lymphatic vessels and our cardiovascular vessels. However, they're not identical. For starters, unlike the blood vessels, where there is both movement away from the heart in the arteries and towards the heart with the veins, lymph only carries fluid in one direction. And what is that one direction? Does it go towards the heart or away from the heart?
Away.
We want to move the lymph away from our heart?
Towards the heart.
Towards the heart. It's going to be towards the heart. So we want to deposit it back into the cardiovascular system, so it's going to carry it towards the heart. Unlike the cardiovascular system, which has the heart pumping, there is no pump for the lymphatic vessels. That means they're going to be dealing with very low pressures. Carrying blood towards the heart, dealing with low pressures. What do these sound an awful lot like? Do you think they're more similar to arteries, or do you think they're more similar to veins?
Veins.
Yeah, they're going to be more similar to veins. Exactly. So like veins, they are going to have valves to help with the one-way flow. In fact, typically, lymphatic vessels have more valves than even the veins do. They're also going to take advantage of the skeletal muscle pump. Remember, that's when our skeletal muscles contract, squeezing the vessels, pushing the blood, and our respiratory pump to help to draw it back as well. So being similar to our veins, our lymphatic vessels are going to need that same type of assistance to help in the movement of that blood against gravity back towards the heart, dealing with low pressures. However, one advantage that our lymphatic vessels have that our veins don't is the larger lymphatic vessels are actually capable of undergoing peristalsis. And someone remind me again what peristalsis is?
A rhythmic contraction of smooth muscle.
Excellent. It is a rhythmic contraction of the smooth muscle, basically milking the vessel and directing the lymph back towards the heart. Excellent, excellent, excellent. Now, with all of this, as we said, it is a relatively slow process, moving on average around 3 liters of fluid a day, which doesn't sound like a whole heck of a lot. But guess how much fluid leaks out of our capillaries in a 24-hour period of time? Yeah, about 3 liters of fluid, exactly. So the amount that leaks out is the amount that it moves back, and that's our goal, maintaining homeostasis. So we are able to do that very successfully. All right, when we talk about our lymphatic vessels, there are several different types. There are capillaries, which of course is where it collects the fluid that becomes the lymph. It is then transported to and from the lymph nodes by what we call collecting vessels. And I'll spoil some of the surprise here. Collecting vessels that carry it to the lymph nodes. How do you think we would identify a blood vessel that carries something towards something?
Using the word vein.
Well, good thought. But remember, all of these are we wouldn't use the word vein because we don't want to confuse it with the cardiovascular system. There you go. That was the term I was looking for. Afferent. Afferent is towards something. So those that go towards the lymph nodes are afferent, and therefore those that go away from the lymph node, how would we refer to those?
Efferent.
Efferent. Excellent. Excellent, excellent. So we're going to have both afferent and efferent collecting vessels. They are going to drain into one of 9 trunks, which are the large vessels that drain certain regions of our body. And those 9 trunks feed into one of 2 ducts. And those 2 ducts are then what deposit that lymph back into the cardiovascular system. So anytime we know there's 9 of something or 2 of something, of course, we know we're going to be responsible for identifying them by name. So let's do that as well. Yes, Daniel, you had a question.
Yeah, so I was wondering, we're referring to them as ducts, but aren't they, it looks like they're more like really large vessels.
Yeah, the ducts are really large vessels. That is correct. Again, this vocabulary, why they're using the terms trunks and ducts, I'm not the one who designed this, but this is how we identify the different organs. So it's the capillaries that feed into the collecting vessels that feed into the trunks, and the trunks that feed into the ducts. All right. But you're right. Yeah. Normally when we think of ducts, we think of our glands. We think of things that are being released out of our body. And obviously that is not the case here. But those are the terms they've used. And here we see this kind of pretty picture overview of showing how this system works. So let's start first talking about the lymphatic capillaries. Notice, not surprisingly, the lymphatic capillaries are interdigitated with our blood vessel capillaries. After all, it is the blood vessel capillaries where the plasma is leaking out, becoming interstitial fluid, and then not getting back into the blood vessel. So instead of accumulating in that area and causing edema and swelling, it is then taken up by these lymphatic capillaries. So they're all mixed together. However, notice the anatomy of them are very different. I'm going to cheat and draw this first, even though I'm not going to do a good job of it. And again, it's not the most it's not the most complicated thing, but I'm going to go ahead and draw this anyway. Our lymphatic capillaries are large, blunt-ended vessels. But one of the keys to these lymphatic capillaries is that they have an overlapping epithelium with only one end of it anchored. So basically what happens is we have this overlapping epithelium anchoring the tissue, forming this lymphatic capillary, this blunt end lymphatic capillary, but only one end of it is basically attached to the surrounding tissue and anchored in place. Think about why this would be advantageous, right? As we have that water, that interstitial fluid, increasing in this area, obviously that causes an increase in the hydrostatic pressure of the interstitial fluid. We know fluid pushes against its boundaries. And as it pushes against the boundary of this capillary, what's going to happen when it pushes against the boundary of this capillary?
It opens up.
Yeah, exactly. What's going to end up happening is that it's going to end up swinging open. And when it swings open, that interstitial fluid comes inside. Of course, that means we now are going to have more fluid inside of our lymphatic capillary. And of course, that means we're going to have an increase in the hydrostatic pressure of what is now our lymph here inside of our capillary. And this is going to push against its boundaries. And of course, when it pushes against those boundaries, it's going to swing it back up and close it. So it's basically like a one-way trap door. Exactly. By anchoring at one side, this prevents backflow. And so now the lymph has no choice but to travel down the capillary, away from the capillary towards the collecting vessels. So as more fluid comes in, it pushes the fluid down the capillary and along its merry way. Yeah, so basically it's made up of these big, huge swinging one-way trap doors to easily allow fluid in. And because they're big swinging doors, not just fluid comes in, but like I said, all sorts of other stuff. Right. Cells, pathogens, dead damaged tissue, all sorts of things can get into these capillaries because of these big, huge swinging doors. Excellent. So here, again, we see some examples of these lymphatic capillaries, big, blunt-ended, large in diameter, with a thin flap-like epithelium. And I think I actually have a pretty picture. Where is it? Oh, there it is. Where we can actually see how it's only anchored at one side, allowing for that flapping of the door to allow the fluid in. Excellent. Now, this is what most lymphatic capillaries look like. But remember, we also said that these lymphatic capillaries play an important role in our digestive system. So not surprisingly, in our digestive system, we have a very special lymphatic capillary. That very special lymphatic capillary is known as a lacteal. Notice it is large. It is large in diameter, blunt-ended, right? Not quite as branching as the other ones were, but it's this big, huge, large structure that goes up into the villi of our digestive system. We haven't talked about our digestive system yet, but our small intestine is specialized for absorption. And one of the ways it is specialized for absorption is it has these long finger-like extensions called villi that increase the surface area of the small intestine. And inside of those villi are these big, huge, specialized lymphatic capillaries called lacteals. And as we talked about, these lacteals are where we're going to be absorbing and transporting our dietary lipids. So our dietary lipids, as we'll learn when we get to the digestive system, end up into these lacteals and are processed before they are deposited back into our cardiovascular system. So all that fat and fat-soluble vitamins and things along those lines go into the lymphatic system before they go into the digestive system. I mean, before they go into the cardiovascular system. All righty. So again, here we have all those one-way doors. Again, big open swinging doors. So not just fluid, but cells and all sorts of other stuff can get in there as well. And they're one-way trap doors, so they have no choice but to continue on into our collecting vessels. As we talked about, collecting vessels go to and from our lymph nodes. So they are both afferent and efferent. And again, this is based on the lymph node. Let's take a quick look at this simple illustration right here. With this simple illustration right here, oops, where is it? There and there. This blood vessel, this lymphatic vessel here, would it be afferent or efferent?
I can't see where you're pointing.
Oh, this arrow is right here. Right here.
Efferent.
Well, really depends, right? It is efferent in relationship to this lymph node, but it's going to be afferent in relationship to this lymph node. Often, again, these lymph nodes are our defenses, our soldiers. And to get this fluid back to our heart, we don't necessarily want it just passing through one lymph node. So it's not uncommon for the pathway to include multiple, if not dozens, of lymph nodes along the way. So whether a vessel is afferent or efferent completely depends on which lymph node we're talking about. So this vessel here would be efferent to the first lymph node and afferent to the second lymph node. So it's not like we can pull that out of the body and say, this is an afferent collecting vessel. It doesn't quite work like that. It's all totally in relationship to the lymph node itself. As we said, it is similar to veins because it is carrying the blood back towards the heart. It is low pressure. Like veins, it is made up of those same three tunics, where we have the tunica intima, the tunica media, smooth muscle, and the tunica externa. Typically, it has thinner walls, and I hate this picture from your textbook because it just shows the endothelium. It doesn't show the smooth muscle or the externa the same way. But again, it's going to have a thinner wall than both arteries and veins. And as we talked about also, much more internal valves as well. Not surprisingly, a lot more anastomoses, because again, remember, those are those alternate routes, parallel routes that again can help us to deal with minor fluctuations in pressure. But the one advantage that our lymphatic vessels have that our veins don't is they can use peristalsis. At least the larger ones can. Speaking of larger, let's talk about our lymphatic trunks. So as they collecting vessels fuse together, they form one of, again, 9 lymphatic trunks. We have basically 4 paired trunks and 1 single. Oops. One of the things you guys were not great about on the last exam was using left and right appropriately. You guys, in fact, were so bad about it that I actually had to go back and start grading again because you guys had lost so many points for not using right and left. I decided to just emphasize it when it was really important. You know, like when we were talking about the carotid arteries or the brachiocephalic veins or, you know, the gonadal or something obvious like that. If it was just one appendage, I didn't hold you responsible for right and left, but you guys were horrible about that. Don't be horrible about that anymore. When we're talking about these lymphatic vessels, make sure you distinguish right or left, or you will get partial credit off for that on the exam. So obviously a paired vessel has both a right and a left. So let's identify those, starting first with the paired right and left lumbar trunks. The lumbar trunks, as you can see here in the illustration, are inferior, down here and down here. And guess what part of the body is drained by the lumbar trunks?
Lower back area.
Not a bad guess because of where the lumbar is, but actually that lumbar is where the trunk is located, which is where it gets its name. But what it's actually draining is actually the legs. So the right and left legs. Bronchomediastinal, left and right. Again, it's one of those alphabet soup words that you know you're going to have to spell at one point or another. But like most of our alphabet soup terms, the name tells you everything about it. Broncho refers to what?
The lungs.
The lungs, absolutely. Mediastinal refers to what?
Mediastinal cavity.
Mediastinum, which is the central part of the thoracic cavity. So notice the bronchomediastinal trunks basically are the right and left side of the thoracic cavity. Right and left subclavian trunks, guess what they drain?
Arms.
There you go. and the left and right jugular trunks. Guess what they drain?
Head, left and
Yeah,
right
the
side of
left
the
and
head.
right side of the head, absolutely. So we have all these paired trunks draining all of these distinct regions of the body. So we do still have one more unpaired trunk, and what's left? Haven't we drained all parts of the body? What are we missing?
The pelvis.
Yeah, the abdominal pelvic cavity, absolutely. We're missing the abdominal pelvic cavity, and the abdominal pelvic cavity is drained by the singular intestinal trunk. There you go. Those are our 9 trunks. Absolutely positively need to know what parts of the body they drain, and on an illustration like this, or an illustration like this, or the great model that we have in the classroom that is available to you. And again, not necessarily here, but I'm trying to remember where, hold on, let's see. I know. No, does it not have the model here? That's lame. Interesting. It even says models and charts. All right. Well, do I have it on ours? All right, it doesn't look like I have it, so I'll get a picture of it and post it for you guys so that you can see it. But there's a great model in the classroom that does a nice job of showing these. You do have the materials in the Sumnus River. If we go, where is it? There we go. Virtual Anatomy Lab, lymphatic system, immune system models. This does a nice job of showing where the tonsils are located. We see those this way, see that way. But we also have a lymph node itself that's really nice in here. But here we can see some of the structures where we can see the trunks. We can see the clusters of vessels. We can see some nice models. So these are some nice charts. Atlas has, I'm sure, has a good picture, absolutely. So there are other places there, but there's a really good model in the classroom that I like a lot that I'll make available because it's useful. All right, back to the lecture. So you absolutely positively need to be able to identify these on the resources that we have. The other thing that I wanted to point out to you on this is notice when we look inferiorly on this chart, we see that, as we talked about, we have the 2 lumbar trunks coming up from the legs, the intestinal trunk coming in from the abdominal region. And then also there is this big enlargement here known as the cisterna chylae. The cisterna chylae is an enlargement where these 3 trunks feed into. And this is one of the locations where those lipids that are absorbed by the digestive system can be housed and stored and modified before they are released into the cardiovascular system. So that cisterna chylae is an important storage and processing location found here in the lymphatic system. Now, as we know, these 9 trunks are going to feed into 2 ducts. And so clearly they cannot do that symmetrically because 9 does not divide evenly into 2. but it's even less symmetrical than that. Notice here, as we look at this picture, this tiny little vessel right here is the right subclavian trunk. Notice this right subclavian trunk is fed into by the right jugular trunk, the right subclavian trunk. Oh, no, wait, hold on, wrong thing. All right, so right subclavian trunk, the, where is it? Bronchomediastinal trunk, and the, why is the subclavian, no, oh, there it is. And the, there we go. That's what I got. Okay. Right jugular trunk, right subclavian trunk, and right bronchomediastinal trunk. Those three all feed into the right lymphatic duct. So those three trunks feed into the right lymphatic duct. And as we know, if they have a right lymphatic duct, what are they going to also have?
Left.
That would be the way it would seem, but as we also know, anatomists hate us. So the other duct isn't called the left lymphatic duct, it's called the thoracic duct. And of course, why is it called the thoracic duct? Well, because the thoracic duct travels all the way up the thoracic cavity. It actually starts at that cisterna chile and comes all the way up and feeds into the blood vessels here on this side. So notice our thoracic duct is fed by the left jugular trunk, the left subclavian trunk, the left bronchomediastinal trunk, and the intestinal trunk, as well as the both lumbar trunks. So if you think about it, well, here, let's do it this way. The right lymphatic duct basically drains the right side of the head, the right arm, and the right part of the thoracic cavity. Whereas the thoracic duct is the left side of the head, the left arm, the left side of the thoracic cavity, and everything below the diaphragm. And again, I've made a bit of a mess of this picture, but let's look at the pretty picture here. A simple illustration that shows that division, and then a slightly more sophisticated picture. Notice one other thing as well. Both ducts feed into the subclavian veins. So the right lymphatic duct feeds into the right subclavian vein, whereas the thoracic duct feeds into the left subclavian veins. Which, of course, as we know, then feeds into the brachiocephalic veins, feeds into the superior vena cava, and feeds back into the heart. All right, so questions on the trunks or the ducts? All right, excellent. As I mentioned, the lymph is that interstitial fluid that needs to be returned. So it's going to have ions and lipids, nutrients and waste, plasma proteins. But remember, because it's this big swinging door, large things and also harmful things can get in there as well. Bacteria, viruses, cell debris, and cancer cells. All right, and that's one of the major concerns. If cancer gets into your lymph nodes, well, then those cancer cells can be directed back to your cardiovascular system. And once they get into your cardiovascular system, where can those cancer cells go?
Everywhere.
Everywhere, exactly. All righty. So, to protect us, luckily we have those lymph nodes. Let's talk a little bit about the lymph nodes. Their job is to filter the lymph before we return it to the cardiovascular system. They tend to be located in clusters. And again, if you have not done so already, one of the things that I strongly encourage you to do over this weekend, because again, we basically have a nice big long 5-day weekend coming up, your interactive physiology. Is a great resource. Again, hopefully you've been using it. It had some great resources for the cardiovascular system, but for the immune response, it has this great analogy of the defense of a castle. And again, that's a lot what this is like. Our immune response is about defending us in the castle. And lymph nodes are guards. And again, I have to work on my analogies because normally if I was in the classroom, this would be the point where I would say, if we had to guard this classroom from invasion, would we take our guards and distribute them equally 5 feet apart around the entire circumference of the room? No, of course. What you would do is you would cluster them around the entryways. You would cluster them around the doors. So instead of having one every 5 feet, you'd put 5 by this door and 5 by that door, and so on and so forth. So not surprisingly, our lymph nodes are clustered in regions that are central points for the redistribution or the return of that lymph. Here we see some examples of some of those. So we have clusters of cervical nodes and axillary nodes and inguinal nodes. There's also pelvic and lumbar nodes. There are all these locations. We can see them in the antebrachial region, or antecubital region, and things along those lines as well. So there are clusters of these in different regions of our body. Excuse me. These lymph nodes then are going to house our immune cells. Primarily, 2 main types. The first are our macrophages. Again, these are outside of the blood, so these are activated cells. And which were the cells that activate to become our macrophages?
Neutrophils.
No, neutrophils are the first to activate, and they do become phagocytes. But which were the ones that became the big eaters?
Monocytes?
Monocytes, there you go. So our activated monocytes are going to be present there, those big, huge, large eaters to deal with any abnormal cells and things along those lines. And they don't want to just eat anything. They want to eat the things that don't belong. So we need a way to tell them what doesn't belong. And that is what our lymphocytes do. Our lymphocytes make our antibodies. Remember, we talked about antibodies a little bit when we talked about our blood typing. So this was a great lead into our immune response. And remember that antibody sticks to something that doesn't belong, like that red blood cell, and it can clump them together, but it also basically waves its hand and says, hey, look at this, I'm attached to something that doesn't belong here, do something about it. And so the lymphocytes basically plant the flags on these bad cells, and then the macrophages find the things that have the flags on them and gobble them up. And so in this way, these 2 cells work together to help to provide our protection. Of course, that means they need to come into contact with the lymphocytes before they come in contact with the macrophages. So we need a precise order and organization to our lymph node. And that we see when we look at the anatomy of it. Lymph nodes, relatively small, about 1 millimeter to 25 millimeters in diameter. They are kidney bean in shape, and what that means is that they have a convex surface and also a concave surface. Whenever we have this type of convex and concave surface, and again, our lungs have this anatomy. There are other organs that are going to have this type of anatomy to them. The indented region is a region known as the hilum. And as you can see, the hilum is where the blood vessels and nerves are going to enter into our lymph node. Notice also we have our vessels feeding into them. On the convex surface, we have the vessels that bring lymph to the lymph node. So on the convex surface, we have the afferent vessels. And then coming out of the convex region, we have the efferent vessels.
The efferent vessels come out of the concave side.
Yes, efferent come out of the concave. Convex is where the afferent come in. So basically, lymph comes in, travels through, not in a direct line, and then out the lymph node. And we'll see that in a minute. Notice also, as we've seen many times in this class, and we'll continue to see many more, our lymph node has a candy-coated shell and a chewing nougat center. When we have that type of organization with an inner region and an outer region, what's the fancy word we give to the outer region?
Cortex.
Cortex, excellent. And what do we call the inner region?
Medulla.
Excellent. So we are going to have a cortex and a medulla, and the anatomy of those and the function of those are going to be different. So let's take a look. We did that. Here we go. Let's take a look at the anatomy. Our lymph node has a fibrous capsule on its outer surface, a dense, irregular connective tissue. What would the purpose of such a fibrous capsule be?
Protection.
Yeah, protection, integrity,
Structure.
give it structure, and also anchor it to the surrounding tissue. However, notice something interesting happens. Some of this fibrous connective tissue that is forming the fibrous capsule actually folds inward, penetrating deep into the cortex, dividing the cortex into individual compartments. These extensions of the fibrous capsule are what we call trabeculae. Trabecula is singular, trabeculae is the plural. And it basically compartmentalizes the cortex of our lymph node into these individual pockets. Notice inside these individual pockets, that's what I want. And actually, that's not what I want. This is what I want. We have these structures that are dense with cells known as a follicle or a nodule, and you may use those terms interchangeably. One of the nice things about all of our lymphatic tissues are going to have these lymphatic nodules, which is both a good thing and a bad thing. It is good because when you see it, they look pretty much the same everywhere. So you know you are looking at some piece of lymphatic tissue. However, if every single piece of lymphatic tissue has this, then we need to rely on other things to tell whether we're looking at a spleen or whether we're looking at a lymph node or whether we're looking at a tonsil. Right? So luckily we have this fibrous capsule, we have this cortex, we have this other organization. Now notice, again, this is an illustration and we'll look at the histology for real in a moment. At the center of this follicle is a much lighter region, a much less dense region. This much less dense region is what is known as the germinal center. These lymphatic nodules contain our lymphocytes. Now, like I said, we haven't talked about our immune response, but one of the things that you probably know, when a lymphocyte comes in contact with a foreign pathogen that activates it, one of the things that it does is it divides rapidly, producing massive numbers of these cells to provide our defense. All right. You may not have necessarily thought of it in those terms, but you're aware of it, because when you're sick, what happens to your lymph nodes? What happens to your tonsils?
They swell.
They swell. And that swelling occurs because of the massive growth of these cells that are occurring inside of these follicles. So this germinal center is where we're going to give birth to the new lymphocytes that are going to provide our protection for our body.
The germinal center's in the medulla.
No, the germinal center is the center of the follicle, which is in the cortex. These follicles are only found in the cortex. So notice here, let's do it this way. This region, orange doesn't show up very well. This region that I've circled here, this is the cortex. And notice the cortex is where you find all of the lymphatic follicles. So follicles are in and only in the cortex, right? And that's the area divided by the trabeculae. That makes this part here in the middle, this is the medulla. And the way we can identify the medulla is that the medulla does not have any follicles inside of it. Instead, it has this elaborate mesh-like structure inside of it, formed by the medullary cords, extensions of fibers, collagen fibers in this space, and reticular fibers in this space, and then all of the spaces inside of them. A sinus is, of course, a space. And this is where our macrophages are located. I actually want to go back to that picture from the website. Excellent. Go back one more. Notice here we see that follicle. Here we see that trabecula. So here's the trabecula extending down from the fibrous capsule. Here we see the cortex, these compartments. They've put a couple of follicles inside of them. And we see all the reticular fibers that are forming all the spaces. And here's the medulla. So if you think about it, if you are a drop of lymph, right? In the last system, we talked about drawing pathways. Let's draw the pathway here. If you're that drop of lymph, you come in through an afferent vessel into the space that is right underneath the fibrous capsule. What do you think the name of that space right underneath the fibrous capsule might be? Oh, if only I'm sorry?
Cortex.
We're in the cortex, but what is this space? If only I had a list of a study guide that told me all of the lab anatomy structures I was responsible for on the exam, I might be able to identify what would the space directly underneath the fibrous capsule be?
Cortical nodule.
It's a space. Yep, spaces.
Subcapsular sinus.
There you go. The subcapsular, right? Don't say subscapular. I guarantee at least one person on the exam will put subscapular on there. No, subcapsular sinus. Absolutely. From there, the lymph would then travel by and around that lymphatic nodule in these spaces next to the trabeculae. What might those be called?
Trabecular sinus.
There you go. Where it would then feed into the medullary sinuses in the medulla and then out the efferent vessel. Notice our lymph takes this very meandering path through the lymph node. Notice, and again, this is just a simple illustration, but there's 1, 2, 3, 4, 5, 6 afferent vessels feeding in and only 2 efferent vessels feeding out. Do you think that that's completely artistic license and why they did that? No. We have more vessels feeding fluid in than we have vessels feeding fluid out. And why might we do that? What would that cause?
Pressure gradient.
Part of it is a pressure gradient, so it does help that way. But I always think of, again, if you're ever driving home to Sacramento from San Francisco, and it doesn't matter what time of day it is, it's 3 o'clock in the morning on a Wednesday. You're going 90 miles an hour down 80, and then you hit Davis. And what happens when you hit Davis?
It sucks.
It sucks. And the reason it sucks is because Highway 80 goes from 14 lanes down to 2, right? And you get, no matter what type of day, you get that congestion that occurs there, which slows traffic down. And that's what we want here. We want that congestion. We don't want the fluid rapidly flowing through the lymph node. We want to have time for it to meander around and come in contact with those lymphatic, those immune cells, so that if there's something that doesn't belong, we can tag it and we can get rid of it. So we want that slow, meandering, congested lymph here in these lymph nodes for this path. So we see that really nicely, and we see those spaces really nicely with this illustration. And of course, anytime I have an illustration like this that I really, really like, you should expect to see it on the exam. All right, excellent. Here we've done it with all the pretty pictures. Now let's take a look at it on an actual histology slide. Again, notice, easy to see that fibrous capsule and that extension of the fibrous capsule that is the trabeculae. Notice it is very easy and clear to see the difference between the cortex up here, where we have all of the lymphatic follicles with their germinal centers, versus here where we have the medulla, where we have the medullary cords and all those sinuses, those spaces in between. Remember, this lymph node is filled primarily with reticular fibers. Remember, reticular fibers are fibers made of the protein collagen. But unlike a collagen fiber, remember, reticular fibers are very short and very elaborately branched. And that elaborate branching gives a lot of spaces inside of it for all sorts of other hunk and junk. And that's what we see. This is actually a colorized, I know it looks like an illustration, but this is using an electron microscope, and they've colorized the image with this electron microscope. We can kind of see those reticular fibers and some of the cells and stuff that would be hanging out in that space. Here we see it with light microscopy. And again, this reticular fiber found here in our lymph nodes always reminds me, again, I don't know how many of you have been back east and have seen cherry blossom trees. The cherry blossom trees are these trees with these large, elaborately branched branches to them with all these beautiful pink flowers on them. And again, it gives this big, huge, open, porous space with this reticular connective tissue. And so these are all of the immune cells, the lymphocytes and the monocytes hanging out inside of that lymphatic tissue. All right, so there's a little bit of the histology and a little bit of the anatomy of the lymph node. Questions on that? All right, remember, as we talked about, the lymph enters through the afferent vessel. It is then going to travel in the subcapsular sinus through the trabecular sinus into the medullary sinus. And then from the medullary sinus, it is going to then flow out the efferent vessel. And there's always more afferent coming in than there are efferent going out to, again, provide that congestion to slow the flow down.
Can you go over the types of tissue again? I think the fibrous capsule
is a dense irregular connective tissue, and
Okay.
the lymph node itself is primarily reticular connective tissue.
Okay, so the lymph node itself, are we saying that's the medullary part?
No, the lymph node itself. So this entire structure is the lymph node. It is
Right.
surrounded on the outside by that fibrous capsule. And the fibrous capsule has those trabeculae that extend down deep into the cortex. So the trabeculae help us to define the cortex of it. The medulla doesn't have trabeculae. The medulla has cords. It doesn't have lymphatic follicles, right? It just has these sinuses, these spaces. But both the cortex and the medulla are primarily comprised of reticular connective tissue.
Okay, thank you for clarifying.
Yep, no, thank you for asking. All right, questions on that? More pretty pictures, all kind of showing the exact same stuff that we just talked about. All right, excellent. With that, we are done with our lymph nodes and our lymphatic vessels. We still have our other lymphatic tissues that we will need to be able to talk about. But I think this is a good stopping point to take our first break. During this first break, hold on one second. Let me see something. What do we have left? Okay, perfect. So here's what I'm going to do. During this first break, I am going to release the instructions for the group presentations so that you can print them out or at least take a look at them during the break. Because when we come back, I think we only got about a half an hour or so of lecture left to go. And then we're going to spend the rest of the time talking about our group presentation, forming our groups, and then you guys will actually have the rest of the class time to work in your groups to come up with a game plan of how you're going to attack this material and of course determine what topic you're going to do. So I want you, again, you don't have to memorize it or anything, but I'm going to make it available now so that you have the opportunity, and actually let me do that while I'm thinking about it, to give you the opportunity to look at it ahead of time, and then we will go over all the instructions together. And then I'm not going to form the groups till after we do that, because if I form the groups before, you guys won't be paying any attention to me. You'll be talking about what you want your topic to be, and I don't want you doing that. So let's go ahead and publish that. So perfect. Our group presentation instructions are now available. So you guys can take a look at that during the break. We'll take a 15-minute break. So come back at 9:27. We'll finish off the lecture, and then we'll move on to the group stuff. All right, so let's go back here. What did I say? 9:27. And we will restart at that point. And I will start the recording. All right, I'll see you guys in 15 minutes. Oh, sorry. It looks like I didn't pause the recording, so everybody got to sit here for 15 minutes and stare at nothing. All right, excellent. Laura asked a good question during the break. Does each subcapsular space have an afferent vessel? What I would say is yes and no. Obviously, it's a fluid-filled space, so it may not have a direct one that feeds into it, but somewhere along the way, there's going to be an indirect route. They're not completely encapsulated. So notice, for instance, with this illustration, obviously, this vessel is feeding directly into this subcapsular space. This one may not have one feeding directly into it, but possibly this one may feed both because of where it's located somewhere along the way. So obviously, all the subcapsular spaces are going to have fluid in them. So either from direct or indirect movement of the fluid from those afferent vessels. Well, you have far more germinal centers than you have afferent vessels. So each one doesn't get its own afferent vessel. Excellent. All right. So any other great questions before we get started? All right. We have talked about the main organs, the lymph nodes and lymphatic vessels, but as we talked about, there are other lymphoid tissues and organs we need to talk about. Some of them are things that you are familiar with, like your tonsils. We have 3 sets of tonsils, and we'll talk about those. The tonsils, though, are part of a larger structure that we call a mucosa-associated lymphoid tissue, which again is exactly what it sounds like. These are lymphatic tissues that are associated with a mucosa. Someone remind me again what a mucosa is?
A permeable epithelial tissue that some form of exchange happens through. Very vascular.
Absolutely, that is absolutely true. They are tissues that some type of either movement in or out occurs through. Absolutely. But the other big key to your definition to a mucosa is that these line cavities that are open to the outside world. Exactly, Allison. You stole the words out of my mouth. Absolutely. So what organ systems then would have these?
Lungs, digestive tract.
Digestive system, respiratory system. What other organ systems are open to the outside world?
Reproductive.
Reproductive and?
Do we do digestive?
Yep, digestive, respiratory, reproductive, and there you go, urinary, absolutely. Those 4 organ systems are open to the outside world. They are lined by mucosa, mucous membranes. And so as you look at these tissues, as we look at the organs, every once in a while, you'll see just a solitary little lymphatic nodule just hanging out in these tissues by themselves. So some of these will be clustered together, but some of them could just be a single structure, a single guard hanging out somewhere in the small intestine or in the stomach or something like that, doing its job. So we'll see those all over the place as we continue through the other organ systems of our body. Some examples of clustered structures are things known as Pyres Patches and your friend and mine, the appendix. The spleen is an important lymphoid structure, and we'll talk about that, and is the thymus. So these are the main organs that are all either lymphoid tissues or lymphoid organs that we need to talk about. Let's talk about the tonsils first. These are lymphoid tissues located around the pharynx. Pharynx is an opening to the outside world. So this is a passageway for food and drink and air. So not surprisingly, we have a lot of guards in there. And a typical person has 4 clusters of these lymphatic nodules forming the things called the tonsils. The first is the singular organ known as the pharyngeal tonsil, or what is also commonly referred to as the adenoids. So if you ever talked about or had your own adenoids removed, that is what we are talking about. Notice the pharyngeal tonsils are up located at the superior part of the nasopharynx, where the nasal cavity connects to the nasopharynx, so up here at the top of the throat, essentially. We have the 2 laterally located palatine tonsils, located between the palatoglossal and the palatopharyngeal arches. And we'll steal some pictures from our from the Consumnes River site to look at that. And then the lingual tonsils, which basically form on the posterior third of the tongue. So let's take a quick look at these, go back to those pictures. So we need to go, this is a good starting point. Notice this is a cross or transverse section through the head. Notice we can see a couple of structures here. The first, where's my highlighter? I think that might be funnest to use for this. Notice here, these two little pieces of chewing gum located on the lateral aspects of the oral cavity are the pharyngeal tonsils. Notice they are located between these two arches. This arch goes from the roof of the mouth, the palate, down to the tongue, so it is the palatoglossal arch. This arch goes from the roof of your mouth down towards the pharynx, so this is the palatopharyngeal arch. And notice there's an indentation in between them. That indentation in between them is the fosse. And in those fosses is where we find the pharyngeal tonsils. The other thing we see really nicely here is that the posterior third of the tongue has this irregular bumpy surface on it there. Notice these big bumps are what are known as the circumvallate papillae. And posterior to the circumvallate papillae is where we'll find those lingual tonsils. Notice if we take a slightly different view, I'll come back to this one in a second. Here we see inside the oral cavity, we can again, and I'll use the line now. Again, there's that palatoglossal arch, the palatopharyngeal arch, right? And then over here on the sides are those palatine tonsils. And here's that dangly thing that swings in the back of your throat, right? Your uvula that we see there. We don't see it, but on the posterior part of the tongue would be where our lingual tonsils would be located. Notice if we take a look at, great question, Laura. So yes and no. If removed fully, then typically the tonsils, the adenoids will not grow back. However, if some of that lymphatic tissue remains when they remove it, then it can actually grow back as a result of that. So it is possible that it could grow back for some individuals, but not for others. Notice again here with the sagittal section, we see again this piece of chewing gum up here at the top, which is the pharyngeal, palatine on the lateral wall, and again here in white represents the lingual tonsils. So again, 4 total that pretty much everybody, unless they've had them removed, have. However, some individuals have 2 additional tonsils, and that's the other reason I wanted to come to these pictures. What I want you to see here, I'm going to switch to the line so it's a little more distinct. Notice there's this fold in the mucous membrane located right here, basically posterior to the nasal cavity. This fold in the mucous membrane actually surrounds an opening that travels to your middle ear. This is what used to be referred to as the eustachian tube, now is called the auditory tube. This is what equalizes the pressure in your middle ear, right? When you go on that airplane trip, or when you drive up to Tahoe for the weekend, you start to get your ears that get all fuzzy or full feeling. And so what do you do to resolve that? Probably because the station was named after good old Bob Eustachian, who named it. I don't have any idea why they changed the name, but it's an antiquated term, but I would accept it if you want to spell it out. What are you supposed to do when your ears get congested? Excellent. Yawn, chew.
Valsalva.
What should the Valsalva maneuver can help. What should you absolutely positively not do?
Stick your finger in your ear.
Okay, well you shouldn't do that. The other thing you shouldn't do is hold your nose and blow. If you hold your nose and blow, I will take participation points away from you. Right, is a horrible, horrible thing to do, because what you could do is actually you could force mucus up into that tube, which blocks it even more and can cause ear infections and other problems along those lines. No, you're not supposed to do it then too. I mean, they do it because the pressure changes are so great there. The risk of ear infection is less than the risk of popping an eardrum. So that's why they recommend you do that when you're scuba diving. But that's just because of the extreme changes in pressure as you're going beneath the water. But it's still not good for your ears. All right. But again, that's a high horse I don't mean to get onto right now. The point of this is that this fold of mucous membrane that covers that auditory tube, in some individuals, there is a tonsil that forms here, known as the small tubal tonsil. Notice if we go back to the illustration from our textbook, they also show, they don't show the fold, but they show the opening of the auditory tube where that small tubal can form. Again, there isn't necessarily anything bad or wrong with it, but as we know, tonsils, when they get inflamed, lymphatic tissues, when they get inflamed, enlarge. And if that tubal tonsil enlarges, it can block that opening. So as a child, if you had a large amount of inner ear or middle ear infections or things like that growing up, it might be because you had those small tubal tonsils. So that increases the likelihood of you getting inner ear infections. No, typically these cannot be removed, but as we grow and get larger, the tonsils tend to relatively shrink in size, and so it becomes less of an issue, right? But again, if you've ever, if you don't have little kids at home, then what I encourage you to go is just go to the nearest playground, find some 2-year-old, grab them and look inside of their mouth, right? Just grab them. Parents don't mind when you do that. You can just randomly grab some kid, open their mouth and take a look inside. If you look inside the mouth of a 2 or a 3-year-old, you'll see their tonsils are massive in the back of our throat. It isn't so much that they shrink, it's just that we kind of grow into them. So as we get larger, the tonsils get relatively smaller, and they tend to have less problems with those inner ear infections from the small tubal ones. Yeah, so pressure changes, loud noises, things like that absolutely can cause. Exactly, yes, for science. Yeah, exactly. Police are police and parents are very, very understanding about those things. Absolutely. I like that. For science, I'm going to totally steal that. That's awesome. All right, excellent. So again, these are providing that defenses. So as Laura mentioned, she had hers removed as a child. Sometimes, especially because of the large size, the palatine tonsils or the pharyngeal tonsils, they can interrupt sleep. They can cause sleep apnea in children. So they'll sometimes be removed for those. Are we weakening their immune response by doing that? Yes. But luckily, they're not our only defenses. So, you know, taking away 5 or 10 soldiers makes your army a little bit weaker, but we still have lots of other defenses. And as far as I know, there isn't any studies that have shown a significant increase in infections or issues with people who've had their tonsils removed versus those that haven't.
When they do remove them, is it the pharyngeal and palatine that they remove, or do they take the lingual also?
They don't take the lingual. It is typically the palatine and sometimes the pharyngeal. And again, those are the ones, especially if they're related with sleep. You know, 30 years ago, you sneezed and they pretty much remove your tonsils. You know, if you talk to your grandparents, pretty much every one of your grandparents had their tonsils removed when they were a kid, because the first time they got sick, they took them to the doctor, they removed the tonsils, they ate ice cream for a week, and everybody lived happily ever after, right? They've gotten a little less enthusiastic about the removal of these. And now primarily it's either due to chronic infections or disturbances of the sleep where they'll get removed now. If you get tubes put in your ear, that's actually through the eardrum to help to equalize the pressure. And that is one of those things where if you have a lot of ear infections or if you have a constant blockage of that auditory tube, that can help to equalize the pressure, help to drain if you've got a lot of ear infections. But those are from the outside through the eardrum. Before they would put them in and then you'd have to have them removed a couple months later. Now they actually have them where they dissolve and then that small hole heals back up. Right, but you're not allowed to swim when you have those. All righty. So here's the problem. We have identified these things, but notice as we look at the tonsil is basically a large cluster of those lymphatic follicles. And like I said, the good and the bad of it is a lymphatic follicle looks like a lymphatic follicle, looks like a lymphatic follicle. So if all I did was just give you this box blown up big, there'd be no way for you to know whether you were looking at a lymph node or whether you were looking at a tonsil. So for these types of things, we need to look at peripheral structures to figure out what is going on. And luckily, the tonsils have a couple of those. Let's start with the easy one. Notice for our tonsil, there are these big, huge, massive invaginations, the kind of places where water and air and fluid and other stuff could get into. What might we call these big, huge, massive invaginations where the water and the stuff in that water could get into these and then therefore be detected by these lymphatic follicles?
Sinuses?
If only I had a study guide in front of me that I could look at and figure out what the correct answer would be. Sinus is a good term. That is definitely the name for an air-filled space. But these aren't sinuses. They've given them a much more fun and spooky name.
Tonsillar crypts.
There you go. Like Tales from the, which I know is a reference that none of you get, but that's okay. Back in ancient times, there was a scary puppet. There was a scary puppet who would show us amazing, scary TV shows called Tales from the Crypt, and so there you go. The tonsillar crypts. So that is those big air-filled spaces. And here's the other thing to remember as well. These are located in the oral cavity and in the pharynx. So as we look, well, that would be awesome. As we look at the surrounding tissue, this is embedded within the oral cavity, embedded within the pharynx. So if we look at the tissue that surrounds it, and sometimes in the deeper crypts, it will line the crypts. What type of epithelial tissue would be found on the mucous membrane that lines the surrounding structures of these tonsils? What type of epithelial tissue do you have in the oral cavity and the oral pharynx?
Simple epithelium.
Would it be simple? Would we want simple there? There you go. I like it, but no abbreviations. NKSSET. What does that stand for?
Non-keratinized stratified squamous epithelial tissue.
There you go. Absolutely. A non-keratinized stratified squamous epithelial tissue. So by noting the surrounding epithelial tissue, by finding these tonsillar crypts, you will be able to identify this as a tonsil. Now, histologically, am I going to hold you responsible? The one that we're looking at now, is it a palatine, a lingual, or a pharyngeal? Is it possible to know? Yes.
No.
Do I expect you to be able to do it? No. So I'm not going to show you this and ask you which one it is. I could show you that head picture and point at one and ask you which tonsil it is. Histologically, you don't have to distinguish which tonsil it is, but you do have to recognize it as a tonsil. All right. Questions on that? All righty. Let's move to the other mucosa-associated lymphoid tissues. Like I said, some of them will just be individual cells located within one region of the mucous membranes: respiratory system, urinary system, digestive system, reproductive system. But there are a couple locations where they cluster and become more distinct. The first of these are what are known as Pyres Patches. Pyres Patches are in the distal part of the small intestine. Anybody know what the name of the distal part of the small intestine is? It's okay if you didn't. We haven't gotten to the digestive system yet. I'm just curious if anybody knows.
Duodenum?
Close. Duodenum's the proximal part, the first part. It leads into the jejunum, which then leads into the distal part, which is the ileum.
Ileum.
Yep. Oops. There you go. Ileum. Absolutely. And the ileum feeds into the large intestine. One of the things when we get to the digestive system, we're going to actually use to be able to identify and distinguish the ileum from the jejunum and the duodenum, because we're going to need to do that, is the presence of these Pyres Patches. These big, huge, prominent lymphatic nodules that are located in this distal part of the small intestine. Why might we want those in the distal part of the small intestine?
To grab the last few things before it enters the large intestine.
That could be useful. However, if you think about it, something harmful that you've eaten has got to pass through the esophagus, through the stomach, through all of the small intestine till the very end. That isn't necessarily where you're going to want to have your guards worrying about things coming from the mouth end. But what's the small intestine connected to?
Large intestine.
And what is the large intestine just chock filled with?
Shit.
True, absolutely. And bacteria. Guess what? Every single one of you is infected with E. coli right now, right? Are you all running to the hospital as a result of that? No, because where is that E. coli? In your large intestine. Exactly. However, exactly, in the large intestine. If it gets out of the large intestine into other parts of your body, that is when it becomes an issue. Right? So your large intestine is basically like this prison containing all these harmful bacteria that, as long as they stay in your large intestine, are fine. But if they start trying to wander their way into the small intestine, right, we need those guards there to be able to protect ourselves from them.
So they sort of function similarly to a valve in that they prevent pathogenic backflow.
I wouldn't say that they work so much as a valve. There is a valve there that does help to stop the backflow. They're there to protect us from anything that may be coming, anything harmful that may be working its way back, any bacteria that may be working its way back from the large intestine into the small intestine. So it does protect us that way. Before we move on, let's see if this is here. That's not what I'm going to want. All right, that's too much work. Doop, 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 doop. So if it's not in the lymphatic, oh, maybe it'll be here. Nope, not what we want. So we'll go to the digestive system. Ileum. Here we see the ileum, small villi in our small intestine, but notice there are these big, huge, massive lymphatic nodules that look just like every single other lymphatic nodule that we have seen. So how are we going to know that these are Pyres patches? Well, two ways. One is that we have these villi that are standing out from the superior surface of this. And if this was a high enough magnification, what type of epithelial tissue would we find lining the inner surface of our small intestine?
Ciliated columnar?
Well, you're right in that they won't have cilia, it'll have microvilli.
Ciliated stratified.
Now, remember, ciliated pseudostratified just in the respiratory system. This will have microvilli to increase the surface area, but what type of epithelial tissue lines our entire digestive system from the distal esophagus all the way to the rectum? See, you thought all that tissue stuff you learned in 430 you weren't going to be using again. Ha ha. What tissue type lines our digestive system?
Columnar?
There you go. Simple or stratified?
Simple.
There you go. So again, the lymphatic nodule, the follicle by itself, isn't going to tell you much of anything. as to where it is. You're going to have to look at the surrounding tissue, the surrounding structures to tell the difference between a tonsil and a Pyres patch and a lymph node and the spleen and so on and so forth. Now, another important MALT structure is the vermiform appendix. And I just called it important. Don't we know that the appendix is just some vestigial organ, like a leftover tail or something that doesn't serve any purpose? No, not surprisingly, as we learn more and more about the body, we learn more and more about it. What the vermiform of course means worm-like structure is a long, narrow tube-like structure lined with lymphatic nodules, connected to the cecum. And the cecum is the big pouch-like structure at the beginning of the large intestine, which is so eloquently is put out to us is filled with shit, or what's about to become feces. All right. Well, I wouldn't say it's no apparent reason, but you've got the right idea, Ash. The goal of this is to have lymphatic tissue associated with that material that's going to become feces, so it can provide some defense against that. The problem, as we know, is that this is a fluid-filled tube. And if these lymphatic nodules find some harmful pathogen and start to swell, that swelling can restrict the opening. And as we restrict the opening, it fills with fluid and enlarges and becomes painful. And what do we call that condition?
Appendicitis.
Appendicitis. And the risk with appendicitis is because of its shape, it can burst, basically ripping a hole in the cecum, which contains all that material that's about to become feces. And all that material that's about to become feces can then spread through the entire abdominal pelvic cavity. And is that something you necessarily want to have happening? I have not heard of berry seeds or things like that causing blockages with that. Or red meat. I haven't heard of either of those things. Again, digestive system isn't my area of expertise, but I'm not aware of that. It's not meaning that it doesn't happen. I'm not aware of that. But yeah, so obviously but I thought that was more of a problem with the digestive system, not so much the appendix. So again, I'm not familiar with that associated with the appendix. So it sounds like the appendix is just bad stuff. So how could it possibly be important? Well, as we just finished talking about, your large intestine is filled with this gold mine of bacteria, this elaborate flora and fauna of bacteria. And it is a massive field of research going on right now. They're spending a tremendous amount of time and money looking at this as we're learning more and more about it. In fact, they believe that variations in bacterial flora and fauna may be the cause of many autoimmune disorders. So intestinal problems, irritable bowel syndrome, immune system disorders, those types of things may be associated with this flora and fauna. So if you could change the flora and fauna of your large intestine, that could improve your condition. And how would they do something like that? If they wanted to change your bacterial flora and fauna, how could they do that?
Fecal transplant?
There you go, a poop transplant, absolutely. If you have the magical combination of bacteria in your feces, researchers will pay you very good money to collect your feces so that they can spin it down, filter it, and get the bacteria out of that so that they can provide those as pellets that are basically inserted into other people to change their bacterial flora and fauna. All right, now, this bacterial flora and fauna is important. The problem is when you get sick or something like that, you take antibiotics, which kill the bad bacteria, but also good bacteria. Or when you eat gas station sushi, that can irritate your digestive system and it can flush much of that bacteria out. What we have learned is that in this fluid of our appendix, there are little seed colonies of our bacteria. so that when it gets flushed by antibiotics, when it gets flushed by having an irritable bowels from something along those lines, then what ends up happening is that these seed populations can be used to actually repopulate the population of our digestive system. So it does actually serve an important function. If you get enough money for it, absolutely. Yep, you can sell poop, get an OnlyFans or something like that. Absolutely. Those things will, again, it's a brave new world out there. All right, excellent. There you go, exactly. Excellent. So again, we already took a look at the histology of this. Here we see another example of these Pyres patches. I'm not going to hold you responsible for the appendix from a histological standpoint, but what I do want to point out is, notice with this higher resolution look, there's two things I want to point out. First, notice we can see the simple columnar epithelial tissue now that lines this, that tells us this is a Pyrus patch. Notice also this one doesn't appear to have a germinal center. Does that mean all Pyrus patches don't have a germinal center?
No.
Does that mean this Pyrus patch doesn't have a germinal center?
No, we probably just can't visualize it.
Right, because remember, we have a three-dimensional structure that we're just taking a single slice of. It's like the core of an apple, right? If you throw an apple up in the air and randomly slice a chunk of it off, are you always going to see the core in that chunk that slices off? No, it totally depends on where you cut it. And that's exactly what's happened here. It's just a more superficial cut of this, so we're not seeing the germinal center. So it doesn't mean there isn't one there. Just remember, we're looking at a superficial cut section through it. So that's why we're not seeing it there. All right, excellent. Two more. Next is the spleen. The spleen is basically the smaller organ that kind of pairs with the liver on the opposite side. The liver takes up the majority of the left side of the abdominal pelvic cavity, and the spleen is a tiny little structure on the left side. Here we see it in relation to the stomach and the liver, relatively small in size. This is the largest lymphoid organ in an adult. Of course, what's the implication there? Adult.
Children have another larger one.
It's different. It's different in the children. Absolutely. This is a very vascularized structure because in many ways, the spleen is kind of like the lymph node of the blood. Its job is to remove dead and damaged red blood cells. Right, absolutely. Erythrocyte destruction. Remember, we talked about those red blood cells only last for about 120 days. So they have to constantly be broken down. We want to recycle the iron. We want to recycle the hemoglobin, things along those lines. So it is going to help in the removal of dead and damaged red blood cells. But again, it doesn't want to just do this blindly. We also want to look for harmful pathogens as well. So notice there's basically two main functions to the spleen. We want to process red blood cells, and we want to provide immunity. So not surprisingly, there are two main components to the spleen, two main types of tissues. So notice when we look at it histologically, there are two main parts. Notice it has some similarities to a lymph node. There is a fibrous capsule on the outer surface. There can be some extensions of that fibrous capsule forming trabeculae. There are things that look a lot like a lymphatic nodule, which are in fact called a splenic nodule or a splenic follicle. Again, those terms are interchangeable. But unlike the lymph node, they're not clustered in just one location. They're spread throughout the spleen. So we don't have a medulla and a cortex. It's just spread throughout. Now, there is one key factor that will help you to distinguish this splenic follicle from all the other follicles we have seen, and it is this structure right here. Notice there is a large blood vessel that goes through the center. Here we see it going through the center. Here we see it going through the center. Notice here it looks a little bit to the side, but again, it's just the angle of the cut. Notice this one, that we don't see it, doesn't mean it doesn't have one. We're just not seeing it because of the way we cut through it. But these large blood vessels that pass through our splenic nodules are called the central arteries. And they're what bring the blood to our nodule, or to our lymphocytes, so that it can be monitored to see if there's anything harmful inside of it. Because this houses the white blood cells, this region is known as the white pulp. The red pulp is where we store all the iron from the breakdown of our red blood cells. So we have our red pulp and our white pulp, the two different regions that are responsible for the two different functions of our spleen. And like I said, they are evenly distributed throughout the spleen. They're not separated into one section versus another section.
What were the functions of red pulp and white pulp?
So the red pulp is red because it's storing the iron. It's breaking down the hemoglobin. It's responsible for breaking down the red blood cells, dead, damaged, abnormal red blood cells, storing the iron. The white pulp is where we're housing the white blood cells that are monitoring the blood to help to provide our immune response. And again, here we see it in a small illustration. Notice here we see a bigger one. And again, red and white more has to do with what this tissue looks unprocessed. So depending on which stain you're using, notice it doesn't necessarily mean that, like in the previous one, notice the white pulp is darker than the red pulp, which you wouldn't normally think. So think of it more in terms of function. The follicles, we can again clearly see the lymphatic follicles. The lymphatic follicles are also known as the white pulp. And then basically everything else is the red pulp. And again, we see a little bit of a fibrous capsule on the outer surface and even a trabeculae, an extension of it there. So again, there's nothing about this follicle that tells you necessarily what it is, except for that central artery. Now, this is not a good example of a central artery. I wouldn't use this one necessarily on the exam. Like the other one was a little bit of a better example, but we can still, if we look closely, we can see it there. Notice these two, we don't really see that. All right. Questions on the spleen? All right, what that leaves us with is the thymus, which is a pretty good lead into our immune response we're going to be talking about next, because it is the thymus that is basically responsible for maturing some of our lymphocytes. In fact, we have a special name for the lymphocytes that mature in the thymus. What do we call the lymphocytes that mature in the thymus?
T lymphocytes.
Yeah, T cells, exactly. You guys may have heard about T cells and B cells. Well, those are mature lymphocytes. B cells mature in the bone marrow. T cells mature in the thymus. So this plays a huge role in our immune response. This is largest during childhood. This thymus in a child basically will cover almost the entire heart with this big two-lobed structure. But as we grow, it tends to shrink in relative size. Again, relative size. So its peak relative size is in a 2-year-old. We keep growing, it gets smaller and smaller. And then by about age 50, it basically becomes indistinguishable from the connective tissue and the fat and the adipose that surrounds the heart and the trachea. Doesn't mean that it goes away. We still have these cells. We still have a need for T cells, but we're not able to produce as much, which again makes sense. We know our immune response tends to diminish with age. And this is one of the reasons for that. As I mentioned, it is a two-lobed organ separated into individual lobules. And it is also an endocrine gland whose job is to produce the hormone thymosin. And it is thymosin that is responsible for maturing and programming our lymphocytes, turning them into T cells. And this is a process we will talk about in more depth next week when we get into our immune response. This maturation is a process that we call becoming immunocompetent. Right? Again, we use the analogy of going to war, defending us, having soldiers. When you take that 18-year-old kid and you send him to boot camp, he comes out of boot camp a soldier, right? Capable of fighting, capable of defending his country. Does that necessarily mean that he's ever fought a bad guy? No, it just means that he's capable of doing what is necessary. It doesn't mean that he's done it yet. And the same thing is true for the T cells. When the T cells mature, they become capable of providing a defense. You may have a T cell that protects you from malaria. But if you never go to Panama on vacation, you may never get malaria, and you could go your whole entire life without that cell ever being activated, never going to war. But it's still there, ready to do its job. And that's what immunocompetent means. It just means it's ready to do its job. And like I said, we'll talk about this a lot more when we get to our immune response. All right. Questions on that?
Professor,
Yes.
going back to the Pyres patches, like you spoke of the medulla, does not have follicles. Does the Pyres patches have follicles? Because I did not see that in the histology.
Yes, the Pyres. So if you here, Pyres patches are just clusters of follicles. So here we have 3 follicles here in the wall of the small intestine. Those are our Pyres patches. All they are a cluster of lymphatic follicles in the wall of the small intestine.
Okay. Does it have a normal range of size, or like maybe 1.2 centimeter or so? Or?
Not relevant. I mean,
Okay.
we don't have a scale bar here, so size would be pretty much meaningless anyway.
Okay.
No, again, it's just within the wall of the small intestine. So any lymphatic follicles you see in the wall of the small intestine are going to be our lymphocytes. I mean, our Pyres patches, sorry.
Thank you.
All right, excellent. With that, that is everything that I wanted to talk about for our lymphatic system. Again, there isn't as much to it. We need to talk more about, I'm going to need my list. We are going to need to, we'll talk more, like I said, next week's going to be our immune response, and then the following week is going to be the endocrine system. We have a lot of material to cover. But what I want to do with the time that we have left is I want to talk about your group presentation. So I want to take a few minutes to go through this handout together and talk about it and what you guys are going to be responsible for. Then I'm going to take advantage of Zoom to randomly assign you into individual groups of 2 or 3 students, at which point you can then discuss among yourselves what topic you want to do or several topics you want to do, and then we'll talk about the assignment of those. All right. So obviously, as it says, you have to be here to be present, groups of 2 or 3 people. I will provide you the rest of the class time today and some additional class time on Monday to be able to work on these. But the class time that I give you will not be sufficient for completing this activity. So you are going to need to work outside of class. Now, you can do that synchronously or asynchronously. Each group, I will make a discussion board specifically for that group so that you guys can share files or communicate in an asynchronous fashion. If you decide to meet up, FaceTime, Zoom, anything like that, you guys are welcome to do that. You are certainly not required to meet in person. If you want to do that, again, I'm not going to stop you, you're adults, but it isn't required. All right, so again, you can do it synchronously or asynchronously. That's completely up to you guys to decide as a group. I don't care how you want to do this. If me, Laura, and Ashley are a group together, and today we decide that I'm doing the introduction in parts A, B, and C, and Laura's doing D, E, and F, and Ashley's doing G, W, and Y, or whatever it is, we can do that. We can work on our parts individually and then put them together the last day or two and however you want. So again, you are not required to meet synchronously. Sometimes it can help, sometimes it doesn't. So you'll have, share contact information if you want to. If you don't, like I said, you'll have a discussion board that you can use that will be specifically for your group to allow you to be able to do any kind of communication that's necessary. You are certainly welcome to go above and beyond that if you like, but it isn't required. Okay. So again, you'll work that out. And like I said, you'll have time today, and we'll also have time in class on Monday to be able to do that as well. So when we talk about this stuff on Monday, you'll get the opportunity then to hopefully work out any kinks. And so it should go smoothly from there. All right. What you're going to be doing today is you are going to be picking out a topic once you form your groups. And that topic has to fall into one of three categories. It has to either be a disorder of the lymphatic system, an autoimmune disorder. And what do I mean by an autoimmune disorder?
Something where the body is attacking itself.
Right. Normally our body's defenses protect us from outside things, but an autoimmune disorder is where your body inappropriately attacks something that is you, or it has to be an immune deficiency. What would that be?
HIV.
It would kind of fall into that category, but it is an example. But an immune deficiency is where you are lacking some part of your immune system or your immune response, right? Either cells or chemicals or something else is lacking from that. And some of that can be caused by viral, or some of it can be genetic. You can be born that way as well, right? So what you are going to do is I'm going to form you into groups. Once you're formed into groups, you will decide on 2 or 3 or 4 different topics that you want to do. And then what's going to happen is one person, because I'm going to stay at the center of this, I will break you off into your own individual groups. One person in your group, and only one person of your group, will come back to the main room. And when you come back to the main room, you will give me your list of topics. And I will tell you which one, right? I only want one group doing one topic. So I don't want 4 different people doing, multiple sclerosis or something along those lines. So based on your list, put them in order of your priority. I will try to give you your top priority, but I don't want multiple groups doing the same activity, the same disorders. So I will assign it at that point. Again, make sure only one person of your group comes back to the main room, because if I have 2 people come back to the main room and 2 people in the chat window, right? In the chat window. If I have 2 people give me multiple sclerosis, I'm going to tell the first person yes, and I'm going to tell the second person no, that's already been taken. And since you're in the same group, that's going to be confusing and causes more problems. So again, stay in your room, send one person back to the main room, and then you'll be able to go back to your group when that is done. Once I approve of your topic, then you can basically use the rest of the time to determine and organize how you're going to do it and how you want to divide the resources and what you want to do for your presentation and everything else that goes along that. You are welcome to use the rest of the class time however you want. So if you want to stay in your group room till the end of the class, that's fine. If you want to break off and go meet at Starbucks and socially distance, that's fine. Again, you're grown-ups, you're adults, you're responsible for this material. So you're welcome to use this time however you want. All right, but Before your group leaves today, you must be assigned a topic. All right, so that's going to be the goal for that. And again, each group will have its own unique, there are plenty of disorders for you guys to find. You can do web searches. You may have some familiarity with some of these, whatever it is that you want. I have a grading guideline that we'll go over that'll show you exactly how I'm going to grade this. You are welcome to use that as your order for how you're going to go through those things. It isn't required. Those are just a list of the things that you need to do. Towards this end, you must have a minimum of 3 references. One of those references can be your textbook, but you do need 2 other outside references as well. And I want you to list those references, make those references available, both for me and more importantly for other students, so that if they are interested about your particular topic, they know where to go to find that information. You will provide these references with your outline. And if you do not provide your references with your outline, or you do not have at least 3 references, you certainly can have more, but if you do not have 3, then you will lose 5 points from your score. All right. You are going to be presenting this information orally as a group, the same way that I'm presenting to everybody right now. And I expect there to be a visual component, some type of slide presentation. And again, you don't have to use PowerPoint. You can use Google, you can use Prezi, you can have a slideshow of photos, whatever it is that you want, but there needs to be a visual component to this, where you're showing images, charts, illustration, and things like that. What I don't want is your script on the screen, because if your script is on the screen, everybody's reading your screen and nobody's paying any attention to you. Again, think of it in terms of how I do my slides. Again, that is not how you're required to do it, but I have key terms, I have vocabulary, I have things like that on the slide, but it isn't every single word I say. Now, that also doesn't mean that you can't have a script. You absolutely positively can have a script. In fact, you can sit there and read your script the whole time. Hell, if you want to hold the script in front of your camera while you read, that is fine as well. Just make sure we can hear you. You are not being graded on how you present this material. You're only being graded on the material you're presenting. Notice 9 times out of 10, when I'm giving the lecture and I'm sharing the screen, you're not looking at me anyway. You're looking at the screen. Nobody's going to be looking at you. Nobody but cares. But if you want to stare at your paper and read your paper while you give your presentation, that is absolutely fine. You're not being graded on how you present, just that the information you are presenting. All right. You will be sharing your screen on Zoom. So again, each group will take control. Someone from that group will present, and then the 3 people will be on camera. You will all be on camera when you're presenting. All right, but like I said, you are not being graded on your presentation skills. You're welcome to read it. You don't have to look at the camera, but you do need to be on camera. And like I said, you'll be small in the corner. Nobody's going to be paying any attention to you anyway. Your presentation needs to be a minimum of 8 minutes and no longer than 12. If it is less than 8 minutes, 1, you probably haven't provided enough information, but 2, you will lose points for being too short. But at the same time, I don't want you going over 12 minutes either. If you go under 8 minutes or over 12 minutes, you will lose points. So it is important to keep track of time. I will try to give you a 2-minute warning if you get to 10 minutes. So just to give you an idea, but I will not stop you at 12 minutes. So if you continue to talk for 15, 16, 18 minutes, we'll all sit here calmly and listen to you, but you're going to lose a lot of points for going over. So keep track of your time, practice, and so be prepared for that. At the end of everybody's presentation, there will be questions. And here is the important thing that I will remind you of. I want this to be interactive. So think of this both as a presenter and someone watching the presentation. When you're presenting and you get done with your presentation, would you rather other students in the class ask you questions, or me ask you questions? Who would you rather ask the questions to you?
Classmates.
Classmates, absolutely. So when other people are presenting, make sure you ask questions of them, because then when you're presenting, they'll ask questions of you. If nobody asks questions, then I ask the questions. There will be question and answer after each presentation, but that question and answer does not count as part of your time. So if you go 12 minutes, we're still having a question and answer. All right. If you only go 5 minutes and then we do 4 minutes of question and answer, that doesn't count towards your presentation. The presentation itself has to be 8 to 12 minutes. And then the question and answer will be after that. All right. You are responsible, come on, for an outline for your presentation. Yeah, I do not want a written report. It is not a written report. I do not want your script word for word of what you're saying. You can make it easy on yourself. If you notice, I post my outlines on Canvas so you have a chance to look at them before the lecture. So since you're doing an outline anyway, if you want to just take and make it 2 or 3 or 4 on a page, actually the 3 on a page is really nice because you have the slides small and then there's spaces to write on the other side. So if you want to print your outline, well, at least from Excel, I mean from Excel it's that way, or PowerPoint it's that way. I don't know how it is for like Google and stuff like that. But if you just want to print your slides and have that be your outline, that's totally fine. You don't have to recreate something separate if you want. If you want a more formal outline, Roman numeral 1 and then A and then lowercase a and 2b and all of that, that's fine as well. You want to make it fill in the blank, that's fine, whatever it is. I want outlines, right? I don't want the students to have to write down everything you say, but I don't want them to have your scripts either. You want to get something that is going to direct them towards the information that they're responsible for, but isn't your script.
Are we submitting outlines?
I'm sorry, go ahead.
Are we submitting outlines as a group or individually?
Group. So I want one outline per group. So you'll work together, put an outline, put your references on that outline, and you will turn it into me. Like I said, on Friday and it's not, I know it says the night before the presentations, but it's not the night before the presentations, it's the Friday. So here, let's cheat. 6 p.m., the Friday, the weekend before the presentations. And again, I've posted it. You have that assignment. You know that that is there by 6 p.m. on the Friday so that people have the weekend to print them out if they want, or at least look at them and do that. It is very, very important you give me the outline so that people have the weekend to prepare. If you do not give me the outline on time, you lose 10 points out of a 50-point assignment, which is a huge chunk. Do not forget. Do not wait till the last minute to submit assignments. So many people turn assignments in 2, 3, 5 minutes late because they wait till right before class to do it and then have computer issues or something along those lines. You do not have to wait till Friday to do it. As soon as it's done and you're ready, go ahead and submit it. But if it is late, you're losing 10 points because I want these posted and available for the students, for all of you, and make sure your references are on there as well. All right. Another important thing you're going to be doing, and is a huge part of this assignment, is relating the material to concepts we've covered or will cover in the class. If your disease involves bones, awesome. We all covered bones back in 430. So you can remind us of how a bone normally works and then tell us how your disease jacks it up. If your disease, on the other hand, involves the digestive system, well, technically we haven't covered the digestive system yet, but we will. So you can say, as we will learn when we get to the digestive system, this is how it normally functions, and this is how my disease jacks it up. So even if it's something we haven't covered yet in class, you basically want to give us the basic concept of how it relates to the class, how this disorder influences some organ system we've learned or are going to learn, and how it normally works, and then this is how it jacks it up. So make sure you relate it to the material in the class. And again, While you are responsible for your material, you are also responsible for being active in the learning process of the other groups. Now, if someone tells us that disease A is treated by medicine X given 3 times a day, every other Sunday, am I going to ask you on the exam what that medicine was that was necessary for that? No, absolutely not. But you definitely are responsible for the general concepts. What type of a disorder is it? What organ systems are it affecting? What are its main symptoms? And what are some of the risk factors, things like that. All that basic information you're absolutely responsible for, and you're responsible for this on both the lab and the lecture exam. And like I said, at the end of every presentation, I expect you guys to ask questions, and if you don't ask questions, I will. All right. That is the presentation. The last thing I want to talk about is how you're going to be graded on this presentation, because this should help to guide you on how you prepare. Again, you don't have to present the information in this order, but this is the things that I'm going to be looking for the grading. Describe the disease. Tell me your disease, what it is. What is the physiological basis of it? Is it that these cells suddenly burst inside of your body, or a bone dissolves in your brain or something? What is it? Describe the physiology of that disease. That's going to be 14 points. How is the disease detected? What are the symptoms? What are the risk factors of the disease? How is the disease treated? Right? And again, some of these things, as I'll say, for many of these, especially autoimmune disorders, do we actually know what causes it? Do some of these actually have treatments that cure these diseases? No, many of these things, what we end up doing is just treating the symptoms because we can't cure the disease. And that's okay. It's okay if we don't know what the cause of it is. Yes, some diseases we know. If this gene is an X version versus a Q version, you're going to have that disease. But others, we don't know the cause. We know some risk factors. We know some things that may be related to the cause. But some of these things, as you'll learn, the answer is we don't know yet. Right? It's one of the interesting and also frustrating things about this. So give me the risk factors, give me the treatments that are available to help people to deal with it. That's 10 points. Again, you need to relate it to the material in the class. And like I said, it has to have some type of visual aid. It doesn't have to be, like I said, a formal slide presentation. I just want visual components. If your grandmother has the disease and you have a video of your grandmother, falling down because of the disease, then great. That's some kind of visual component. We need some kind of visual component, something that you are showing us in some form that, again, relates to what we are learning about. And that's worth 6 points. And you put that all together and you get your 50 points for the presentation. All right. Questions on that? Really? No questions?
No question, Professor.
Yes.
With the group outlines or outlining, are we to speak like maybe after one outline to another? Like, for instance, one person speak on one topic within the outline, and then the next person speak on the next topic. Like
So
the same
yes,
topic, yeah, but it's going to be like, I don't know where.
So again, all the people in a group need to be involved in the presentation. Okay.
Yeah.
But how you break up the information is completely up to you. If you as a group decide, all right, well, I'm going to do the first part and Laura's going to do the second part.
Exactly.
Ashley is going to do these 2 parts. If you want to do it that way, that's fine. If you decide to organize it differently and do different parts, that's fine as well. Again, I require that everybody be involved in the presentation, but how you do it is up to you as a group to decide. If Ashley is completely terrified of talking in front of groups and just wants to do the introduction, and then Laura and I are willing to talk more and we decide that that's okay as a group collectively, then that's okay. But Ashley's going to need to make up for that some other way. Maybe she'll make up for it by she'll be the one that writes out the outline or something like that. You are all getting the same grade for this. So it is important that you work together and you evenly distribute the work. Everybody needs to spend some time presenting, and everybody, but how you divide up the workload is completely up to you. Yes, Daniel.
Are we required to define in the outline or some other document what each group member's role was for the purpose of grading, or does it not matter so long as we get results?
Does not matter so long as you get results. If there are problems with the group, then obviously I want to be made aware of it. So if Laura, being the slacker that she is, isn't showing up for the meetings, isn't doing the work, and Ashley and I are doing everything and Laura's nowhere to be seen, then me and Laura need to let, well, me know that something that is going on. But if you guys get together and present your material at the end of this, I'm going to assume that you guys, being mature adults in college, evenly distributed the workload so that you all get the same grade.
Do we get graded as a group or individuals?
As a group. So each group will get a grade as a group. So you'll get a group grade based on your presentation. The material that you're presenting, the outline, the visual, and these factors. All right. Any other questions? Great question, Sarah. So how you do the references, I don't care. They can be websites, they can be books, they can be journal articles. And again, I don't care the format. Basically, what I want from those references is that if, right, Allison realizes next week that her grandmother got one of these disorders that you talked about, and she wants more information, I want her to be able to go and get that resource. So yeah, website or the journal, I don't care so much about the format as long as we are able to access that material so that if people want more information, they can easily find that more information that you use. So that's what I'm looking for. So I don't care about the format of the references as long, and it can be websites, it can be, books, it can, like I said, your textbook can be one of them, but you need at least 2 other outside resources. And absolutely, they can be websites and other things like that. Yep. All right. Questions on that? All right, looks like we have all 33 people who are enrolled in the class are here. So that to me means that all the groups are going to have 3 people in it, and we're going to have 11 groups. So what I'm going to do is just have it randomly assigned you guys to groups of 3. Once I get these set up, I will go ahead and move you guys into the groups, and then you guys will get the invite into your breakout groups, and you guys can start talking. I need to, how am I going to do this easily? I guess I can take a quick screenshot or something like that. And then I will set up, so while you guys are meeting, I will be setting up the discussion boards. Like I said, once you decide on a topic, then one person and one person only from your group come back to the main room and tell me what topics you want, and I'll tell you what is available and which one you can possibly do. All right. Any questions on any of that? So once your group has been assigned, so great question, Sarah. Once your group once I've approved your topic for your group, then yes, the rest of the class time is for you to use however you guys want to. I would encourage you to use this class time to come up with a game plan of how you're going to attack this material. You're expecting to be here for a couple more hours anyway, so use that time, but you're not required to use all that time. If you guys get it broken up in 15 minutes and then you're comfortable, or if you guys want to go get coffee and then set up your own Zoom meeting some other time, that's fine. Again, at this point, this is college, you guys are adults. And that is that. The outlines are not due this Friday. They are due Friday, March 5th. So basically the weekend before our presentation. Presentations are Monday the 8th. So Friday the 5th, the weekend before, is when it's due. So again, you guys have plenty of time. This isn't due till March 8th. Plenty of time to do this. And again, the one last thing before I break you off into groups that I want to strongly remind you about is that, yes, this presentation is important, but don't let it be all consuming. One of the errors I see people make is they spend too much time on this presentation. This presentation is important. It's a 50-point assignment, but at the same time, how many points is your lecture exam worth?
100.
100. And the lab exam for this, my guess is probably somewhere around 65, 60 to 70 for this lab exam. So while it is a big chunk of points, your lab and your lecture exam are more points. Don't forget about studying the material. There's a lot of material and it's dense material. So you want to work on your presentation, but you also need to stay up on all of the material that we're covering in class as well. Because it's, like I said, not necessarily intuitive stuff because it's more cellular and chemical interactions and things like that. Okay? All right, I'm going to go ahead and send you to your rooms now. So hold on, let me do this real quick. I want to take, actually, I guess the easiest way to do this is to take a picture of it. So there. Perfect. All right. So I have your groups. You guys go to your groups. Once you come up with a list of at least 3 topics, come back to the main room and we will do that. So here we go. All right. Off to your rooms you go.